All right, welcome back. Chapter 2, Section 7. Use absolute value functions and transformations. So, an absolute value function. Comes in two forms. Y equals the absolute value of x, which is the parent function. And then y equals the absolute value of a, x minus h, plus k. We're going to talk about the child function a little bit more. Absolute value functions are graphed as a v or as an upside down v. The vertex of an absolute value graph is you could just call it the point of v. You could also say that it is the highest or lowest point on the v. A transformation changes size. A translation shifts the graph. And a reflection takes a point, and I guess you could say it flips it, or it uh, gives it a symmetric point over a line. So basically, you'd have a V, here's a line. So this point here has a reflected point on the other side. This point here has a reflected point on the other side. This point here has a reflected point right there. And what you have is you have now a V shape that's been reflected over that line. All right, so parent function for the family of all absolute value functions is this. Y equals the absolute value of x. The graph of y equals x is blank and is blank about the x-axis. Is V-shaped and is symmetric about the y-axis. So for every point xy on the graph, there is the point negative xy is also on the graph. It's basically right here. This is 4, 4. It has, here is the reflection line of symmetry. This point is over here as well. The highest or lowest point on the graph of an absolute value function is called the vertex. And the vertex on the graph y is 0, 0. So for the parent function, it goes through vertex of 0, 0. All right, so I talked about earlier a parent function, y equals the absolute value of x. Pretty basic, pretty straightforward. The child function has a few extra pieces. A plus k. So A determines whether it opens up or down. A also determines whether it's narrow or wide. The points HK is the new vertex. So basically what happens here is the A value, A, provides a transformation and the HK provides a translation. It actually moves it around, changes it, shifts it, if you will. So, comparing these. The graph of y equals 1/3 x is the graph of y equals x vertically stretched. Oh, I forgot to put this. Okay, so this is how you'll know how to whether it's stretched or shrunk or something like that. So the graph is vertically stretched if a is greater than 1. And y equals the absolute value of ax is narrower. Then it's the other way around here. If it's less than 1, it's vertically shrunk or compressed, and it is wider. So here we go. So for this one, 1/3 is the graph, which means it's vertically shrunk by a factor of 1/3. The graph has a vertex of 0, 0 and passes through some points. Well, these 2 points, let's find one of them. For 1/3, let's make it 3, because 1/3 of 3 is 1, and 1/3 of -3 is also 1. So 1, 2, 3, 1, 1, 2, 3, 1, 0. Oops. There you go. So this has been vertically shrunk and is wider. This one, A is greater than 1, so it's vertically stretched by a factor of -2, and then blank in the x-axis, reflected in the x-axis. The graph has a vertex of 0, 0 and passes through some points. So let's choose 1, the absolute value of 1, so 1, -2, and -1, -2. So plot 0, 0, 1, -2, -1, -2. Oops. You can say that it is closer. Good. You can say that this one is narrower. Narrower than the original. All right. So let's do another one here. So this y equals 3x starts as a nice absolute value equation like this. Okay. But then you say that since a is greater than 3, that means that it is stretched and is narrower. A vertex at 0, 0, another point at 1, 3, and the reflection point is -1, -3. So 0, 0, 1, 3, -1, 3, and you can see just from the graph that it's narrower than the original. All right, so now we have the child function. So the child function looks like y equals a x minus h plus k. So what you need to do and what you need to start thinking about is right here, you need to say that this is what makes this x minus h equal to 0. Well, what makes x minus h equal to 0 is hk. So for our situation, what makes x plus 2 equal to 0? Well, that would be a negative 2. So it's at negative 2. And then k is just k minus 1. So we've now done a translation of from 0, 0 to negative 2, negative 1. That's our new vertex. Plot another point. Throw in a 0, if you will. Let's see here. Put a 0 in here. Negative 3, 0 plus 2, minus 1. Negative 3 times 2, minus 1, that's negative 6. That's negative 7. So about right here. Which means there's a reflection point right over here. So 0, negative 7, which means 2 away is also negative 7. So negative 4, negative 7. With a v, and there you go. So compare the y equals the absolute value of x with what is given. First, it is stretched vertically by a factor of 3, then reflected over the x-axis, and finally translated, let's see here, 2 units left and 1 unit down. Guided practice 1 and 2. So we have to graph for number 1, y equals the absolute value of x minus 2 plus 5. Well, hk is the vertex. Well, what makes this equal to 0? Just this number is the vertex. So 2, 5 is the vertex. Now, a second point. Let's just go ahead and choose 0 again. So let's put 0 into the equation. 0 minus 2 plus 5. That would be negative. That's the value of negative 2 plus 5. That would be 2 plus 5. That would be 7. So 0, 7. And that means then this would reflect over to here. And your V shape, should look like something like that. I'll try to draw this point a little bit better. There you go. So that's guided practice number 1. Take a look at number 2. Or not number 2. I think you had to do number 2. So number 2 says y equals 1/4 x. But 1/4 of the absolute value of x. So this means it's going to be wider, but the vertex is 0, 0. Second point would be 4, 1, which means a reflected point would be negative 4, 1. 0, 0, 4, 1, negative 4, 1. You can definitely see that this thing is wider than its parent function that would look like this. All right. Example 3. Now we have to come up with an equation. To write an absolute value equation, I think we should probably give some steps. Step 1, so plug in the vertex, plug in the second point, solve for A, and then the final one is to plug into the child function the vertex and the A value. X and Y stay for your final answer. So add these notes to the side and then go ahead and give them a try. Okay, so follow those 4 steps when you're doing this example problem. Looking here, the vertex, which is the highest point of this V shape, is 3, 2. So the equation has the form y equals ax minus 3 plus 2. Then, number 2 says to plug in the second point. Here is the second point, 1, negative 2. So now you have negative 2 equals a, the absolute value of 1 minus 3 plus 2. All the variables are gone except for a. So solve for a. Well, this might take a little bit of extra work here. Negative 2 equals a. So 1 minus 3. Absolute value of 2. That makes this 2a plus 2. Let's subtract 2 from both sides. Divide by 2. And now a equals negative 2. So a is negative 2. Now, once you have your a value, plug the function and plug in the vertex, put in a, and leave x and y alone. So y leave alone, plug in a, leave x alone, put in the vertex of minus 3 plus 2. That is your equation. So graph this, compare it with y equals the absolute value of x. Think about the child function. You should know where the vertex is. What makes this part equal to 0. And then the minus 2. And find another point. So 1, negative 2 is the vertex. There's the vertex. Let's find a second point. So let's put in here a 3. If you put a 3 into the equation, negative 1 half. Absolute value 3 minus 1. That's negative 1 half of 2. That becomes negative 1 minus 2, negative 3. So when you put in 3, you get negative 3. That means if you were in 2 places this way, you'd be a vertex right there as well. Now I want to point something out here that I don't know if it says it in your textbook, but there's another way you can think about this. The a value is also could be considered the slope of the line. All right, it's the slope of the line, so that if you started here you'd go down 1 over 2, and then down 1 over 2 in the other direction. And then you can just draw your line through. The key, though, is making sure you know which way it opens. I think at the beginning I said if A is negative number, it's down. If A is positive, it's up. So I'll probably do it, it's faster this way for me than to come up with this other point. All right, so write an equation for this. So we should flip back to the steps, the 4 steps. So it's to plug in the vertex and plug in the extra point. So looking at the child function, y equals ax minus h plus k. H is negative 1, k is 3. X is negative 3, and y is 7. So plug all that information in. Y is 7. I don't know what A is. I do know that X is negative 3, that H is a negative 1, so minus a minus 1, and that you're then adding your K value. So all I did was I took all these little pieces here and plugged them into an equation. So I get 7 equals A, the absolute value of minus a minus is a plus. It's negative 2 plus 3. Absolute value of negative 2 is 2, so you end up with 2A plus 3. This kind of looks like a mx plus b equation at this point. Minus 3, 4 equals 2A, so A is 2. So now I know HK, I know A is 2, so when I write the equation, and remember I want to do minus 1 plus 3. So minus a minus is a plus, remember. So you might as well just get rid of those extra negatives there and just make it a positive. So your equation is x plus 1, absolute value of x plus 1 plus 3. All right, so that's graphing your absolute value functions. Let's see, is there some check your, okay. All right, so transformations of general graphs. The graph of y equals a times this can be obtained from the original function. Let's just fill in these blanks for you. I'll fill them in. All right, go ahead and fill in those blanks, and we're going to talk about a different way you can go about solving these types of problems. All right, so for these, basically there are 2 general rules. Anything that happens, anything that's on, or I guess I should say anything outside of the parentheses affects the y. So whether if you're multiplying, if you're subtracting, dividing, whatever you do, whatever happens inside the parentheses affects, or outside the parentheses affects the y. And then anything inside of the parentheses it affects the x's. So basically if I had 2f of x like this and a plus 3, Well, if my point was 2, 3, is there anything happening inside the parentheses? Hopefully you say no. So that means the x's are left alone. Now, what's happening to the y? Anything outside? You're multiplying by 2 and adding 3. So multiplying by 2 gives us 6, and then adding 3 gives us 9. So you can just think about each individual part and then graph both. So in this number line, or in a graph, 2, 3, point 2, 3 would get stretched out to 2, 9. Okay, it got doubled and then got pulled up by 3. So let me delete this one. All right. So looking at this, here are your points. Here's a 0, 4. Is there anything happening inside the parentheses? Hopefully you'll say no. And only thing that's happening is the y value is getting cut in half. So 0, 4 gets cut in half. Becomes 0, 2. 1, 1 gets cut in half and becomes 1, 1 half. 4, 3, the 3 gets cut in half and becomes 4 and 3 halves. So now apply your points. 0, 2, 1 and 1 half, 4 and 1 half. So basically this has been shrunk, which is what this said to do. A was less than 0, then you just shrink the graph. All right, take a look at this. There's a bunch of stuff happening here. There's some things happening inside the parentheses now. So let's go back to this and let's add a little note here. When it's inside the parentheses, like x plus 2, you have to think, what makes this equal to 0? Well, a negative 2. So that is what you do to the x, is minus 2. So come on over here. Actually, let me delete this. So the x, let's take 0, 4. The x has a minus 1 here. So to make that equal to 0, you would plus 1. So that means the x now becomes 1, because you plus 1. The 4 gets multiplied by negative 1, becomes negative 4. Then subtract 2 from both sides. All right, so I'm not sure where I left off after I paused that. But we already multiplied by negative 1. So now you have a plus 2. So your new point, you went from 0, 4, and now you should have flipped it. You're going to flip it. You're going to do some other stuff as well. So 1, negative 2 now. I don't know if it's possible to even get it on this graph. 1, negative 2. So this point here flipped over, got moved, and is now at 1, negative 2. So let's take a look at 1, 1. You're going to add 1 to both, add 1. So it's now at 2. And what do we do here? We multiply by negative 1. So now it's 2, negative 1. Now there's nothing else inside the parentheses, so now you simply add 2, and so your second point is 2, 1. So you took this point, you reflected it over the x-axis, and then you moved it. All right, so take 4, 3, and you add 1 to the 4. Multiply that by negative 1. That's your first change. Then we add 2 to the, and you get 5, -1. So what you've done is you've now have a new shape that got rotated over. All these points got flipped over the x-axis and shifted around. So it ends up looking like that. All right. This video is long enough, so we're gonna go ahead and do some of those guided practice in class, but we'll do these as well. Good luck.